we like to find the centroid of this plate, and in this case we will do the approach of using a horizontal strip. So we will find the centroid in X and Y. This is the strip that we will use to do that, and where this is the Y and this is X. Therefore, my differential of area will be X dy. The area of this triangular plate, we know that is base times height divided by 2. We could do it also by integrals, but I have done that already in another video, so I will just use the formula for area, right? A triangular area, which is 16 meters square. Okay, so having the area, we know the definition of centroid. We have that the centroid will be the centroid of my differential of area, the area divided by the total area. And the centroid of that total area, as you see, we need to find the centroid of the area that we are using to integrate. In this case, the centroid of that area is located at x half. This is the centroid of the area, as you see. So therefore, we have to use the centroid of the area, which will be x half, and my differential area will be x dy. The area and the limits of integration corresponds to the variable of integration. In this case, it's from 0 to 8. So, and we have to write x in terms of my variable of integration, which is y. We need the equation of this line, and you see that the slope will be y over x. Y is equals to negative 2x plus 8. Therefore, if I solve for x, x will be equals to 8 minus y divided by 2. So I can substitute here, and I will get that this is from 0 to 8 meters. I can have that 1/2 outside, and I have the area, of course, is 16, we already know, and then we have x squared dy divided by 16. So let me write that correctly a little bit better. So this will be 0, and this is 1/2. So that will be then equals to 132, and my integral is from 0 to 8, and I can say this is 8 minus y over 2 square dy. And then I can say that this is 132 times 4, right? Because I can take this 2 square out of the integral, and I have the integral from 0 to 8 meters, which will be 64 minus 8y plus y squared, the y. And then my integrating those terms, I don't have to do the multiplications because at the end many terms will cancel out, and this is 64y minus 2 times 8, let me multiply that, 16 times, this is y, this is y squared over 2 plus y cubed over 3. And all that evaluated between 0 and 8. So the result will be that if we evaluate all that and cancel out all what we have to cancel out, we get that x is located at 4/3 meters. And this is the expected result because we know that it will be a 1/3 of my base. I will do the same for my y, and in this case, my centroid of my area, differential of area, is all located at the same distance y. Therefore, I don't have to divide by 2 or anything. So my integral will become y, and differential of area will be x the y, and the limits of integration from 0 to 8 over 16. I have to substitute the value of x in terms of y, right? And again, this is 0 to 8, y, and x is 8 minus y divided by 2, the y. All that over 16. So I can pull out that 2 out of my integral, and I get 32, and the integral will be from 0 to 8 meters. 8y minus y squared dy, and that's a very easy integral, which is 8y squared over 2 minus a y cubed over 3, all that evaluated between 0 and 8 meters. When I evaluate that, I will get that y is equals to 8 over 3, which makes sense because it's 1/3 of the height. Again, so for a triangular plate, my centroid is located at 1/3 of the base, in this case is 4, and 1/3 of the height, in this case is 8 meters, and this is 4 meters. And this is the location of my centroid of a triangular plate. Okay? This is the solution of this problem.